Okay, so for elements, the molar mass is the mass of 1 mole of atoms. For compounds, the molar mass is the mass of 1 mole of molecules, if it's a molecular compound, or formula units of that compound. So in that very last section of chapter 5, we talked about the formula mass for a compound. And we just took the mass of each atom in there and added them up. This is the same idea, but we're adding up a mole of each. And if there's 2 atoms in there, then it's 2 moles. So ionic compounds don't contain individual molecules, and that's why we say formula units. Okay, and that's hard for some people to get their minds around. If that just is really, really bothering you, think of them as molecules, but they aren't. I can't tell you they are. So we can use the mass of a compound and the moles of a compound. We can convert and calculate the number of, I don't even know what I'm saying. I'll just read it. We convert between the mass of the compound and moles of the compound, then we calculate the number of molecules or formula units for moles. I'm losing my mind. The molar mass of a compound in grams per mole is the same number as the formula mass in atomic mass units. Okay? So we just add them all up. So let's calculate the formula mass of calcium nitrate. It's the mass of the formula. This is the formula unit. This is an ionic compound. So to do that, we need to know, well, how much does 1 calcium atom weigh? 40.08 atomic mass units. That's 1 calcium atom. How many nitrogen atoms are in this formula?
2.
2. Okay, so 2 times the mass of nitrogen. And how many oxygen atoms? 6. And so the average mass of oxygen is 16.00 atomic mass units. So we add them up. One formula of this would weigh 164.1 atomic mass units. Now, atomic mass unit is a very, very small unit. It is useful for measuring masses of formulas and molecules and atoms, but not for quantities that we can actually see. Yes?
Would you still consider the precision and significant figures by step for formula?
That's an excellent question. What about significant figures for this, right? So there's a couple of different ways you can think about it. I don't think we need to waste thinking power, because let's face it, we have a limited amount of thinking that we can do in a day, right? And you've probably been over that every day now since you started this class, right? And your brain just like is shutting down. So let's not stress out about these, okay? I think the simplest thing, because essentially this is all adding, if you just do it on your calculator, you are not going to end up with tons and tons of extra digits like happens when we multiply and divide. At most, you'll end up with 1 or 2 extras. It's not going to cause a problem. The molar mass or formula mass is generally not the thing that's going to limit your significant figures, so it doesn't even matter from that standpoint. So what I recommend is whichever masses you use, just write down what your calculator says and go with that. That won't cause any problems. Is that a rigorous looking at significant figures? No. Is it good enough? Absolutely. So if we want the molar mass, the mass of 1 mole of those formulas, what is it?
164.1 grams.
164.1 grams. It's the same number, but the unit is different. Here, formula mass, we're talking about 1 unit containing 1 calcium atom, 2 nitrogen atoms, 6 oxygen atoms. Here we're talking about the molar mass, the mass of 1 mole of this compound. So 1 mole of calcium, 2 moles of nitrogen, and 6 moles of oxygen. The numbers are all the same, you just change the unit. Any questions? We introduce atomic mass units to you. We talk about those here. Just like Avogadro's number and counting atoms, we don't often use that in practice, but we need to know what those things are. So mostly we're going to use molar masses and grams. So find the number of moles in a 22.5 gram sample of dry ice, which is solid CO2. So 22.5 grams of CO2, and what do we want? Moles. Well, we can go from grams to moles in one step. We need to know the mass in grams of 1 mole of CO2. I would encourage you to show your work for this. So I've got 1 mole. I'll show you how strictly the units work out here. I've got 1 mole times 12.01 grams of carbon per mole. And I've got 2 moles of oxygen, 16.00 grams per mole. And I think that comes out to be 44.01 grams of CO2. That's the mass of 1 mole of CO2. Any questions? So it's the same thing here. I'm taking the number under the element symbol in the periodic table, multiplying it by how many of those are in the formula, and I'm just slapping the unit gram on it. That's the mass of 1 mole. So when I do this conversion, I've got 22.5 grams of CO2. I'm going to have 1 fraction with moles on top and grams on the bottom. 1 mole weighs 44.01 grams. So 0.511 moles. Any questions?
Yeah. Why didn't you just do what we've been doing and do like the one equation? Where did the other equation come from?
Where did this one come from?
Yeah.
Okay, so here I'm using a compound instead of an element. So I can't just go to the periodic table and say, oh, the mass of carbon is 12.01 grams. I have to combine that with 2 oxygens. So if the molar mass of this isn't given to me, I need to calculate it.
So instead of doing individually, like...
Yeah, you don't want to put the mass of carbon and then the mass of oxygen. That's a recipe for a wrong answer. Does that make sense?
Mm-hmm.
This is a little side calculation. And question back there.
So to make sure, like, step 1 would be find the formula mass, step 2, use that to convert from grams to moles.
Yeah, you need, this is technically not the formula mass, it's the molar mass. You need the molar mass, and that is the conversion factor to go between grams and moles. So if you just look at the units, and you're starting with grams, they're asking about moles, you fill this in according to that pattern. The conversion factor between grams and moles is always the molar mass. And we get the molar mass by adding things up on the periodic table. Now, be careful with your units. I don't remember people doing this a lot before, but lately my students have been using M for moles. That's not moles. That's meters. MOL isn't short enough for you? MOL is moles. ML is milliliters. Okay, these three are similar, but they're very different, and so we need to be careful when we write our units, okay? You cannot make up your own abbreviations. It's set. The International Union of Pure and Applied Chemistry said that the abbreviation for moles is MOL. You can't make it shorter, sorry. Find the number of moles of NO2 in 1.18 grams of NO2. We got 1.18 grams of NO2. And they want moles. Grams to moles is one step. Put moles up here. And grams down here, the units cancel out, everything's good. We need a number. We need to do a calculation because NO2 is not on the periodic table. Right? N is on the periodic table and O, but not NO2. So in the last slide, I wrote the whole thing out with all of the units. I don't think that's necessary every time when you calculate a molar mass. Here, look at the formula. There's one nitrogen, so write down the mass of nitrogen. There are two oxygens, write down the mass of the oxygen. 14.01 plus 2 times 16 equals 46.01. That means that 46.01 grams of NO2 is equal to 1 mole of NO2. I highly encourage you to write this out, because if you do it in your head, it's easy to make mistakes. So 1 mole is 46.01 grams. I'm looking at the 3 significant figures I started with. It's more than what's in here. So I'm going to keep 2, 5, 6, and then I wrote those down out of habit, and now I'm going to round it, and there's the number of moles. Any questions? Yes?
So do you want us to be rounding if it's like an insignificant number, or do you want us to like write out the full number?
So for these molar masses, you can, I would not round them to less than 4 significant figures. I think the periodic table I give you for exams has 4 significant figures. That's enough. Don't round them to 3 or 2 or 1. That will cause problems. If you want to use the whole number on whatever periodic table you're looking at, that's absolutely fine. It's better, but this is faster for me. Yeah.
Will the units just be moles, or would it be moles to nitrogen?
Well, it would be moles of NO2. Yeah.
And do we have leading zeros? Or can we-
Well, you can't just throw out these leading zeros.
So I could write it in scientific notation.
You could write it in scientific notation, yes. So 2.56 times 10 to the negative 2 moles of NO2. But you can't just say 0.256 because that changes the number.
Mm-hmm.
And also, something students sometimes forget is this leading zero doesn't count as a significant figure. They'll go 1, 2, 3 and stop at the 5. No, that's wrong. Zeros don't count at the beginning. So at 2, 5, 6, this is where I want to stop, the 6. Any other questions? Okay, so we got 3.64 grams of water. How many water molecules? .64 grams of water. And we want to know how many molecules. There's no abbreviation for the word molecule. How dumb is that? So I want molecules. We could do this one of two ways. We could go from grams to moles to molecules, or we could go from grams directly to molecules. Somebody tell me which one to do. Grams to molecules. We're going to go direct. So we follow our pattern, and we're going to put molecules up here, and grams down there, so the units work out. And then we need to know the mass of a number of molecules.
For what?
Well, we need numbers here. We've got some number of molecules and some number of grams, and we need to know what to put in there. Well, we can calculate the molar mass of water, right? 2 times the mass of hydrogen plus 1 oxygen, 18.01 grams of water. And that's equal to what? 1 mole of water, right? That's the molar mass. 18.02 grams is equal to 1 mole. Well, how many molecules are in 1 mole? 6.022 times 10 to the 23rd molecules. So if this mass is equal to 1 mole and 1 mole equals this, then this mass has to equal that number of particles. So Avogadro's number of molecules, which is 1 mole of molecules for water, weighs 18.02 grams. So 3.64 times 6.022 EE 23 divided by 18.02, and I get 1.2164 times 10 to the 23rd molecules. Yes.
What's the difference between molecules and atoms?
What's the difference between molecules and atoms? That's a good question. So an atom is the smallest piece of an element that you can have. A molecule is 2 or more atoms that are chemically bonded together. So if you think in terms of Lego blocks or something, they are attached to each other. They're not just sitting next to each other, but you actually clicked them and stuck them together. So a molecule is 2 or more atoms that are bonded together. And that's true for molecular compounds. It's not true for ionic compounds. They don't have molecules.
For an equation like this, we always just put Avogadro's number for molecules.
Yeah, if anytime you're dealing with number of molecules, number of atoms, the number's going to be Avogadro's number. And that's equal to 1 mole. And then we know the mass of 1 mole because we can calculate that. If skipping the step and combining these is confusing to you, don't do it.
So will the number of molecules and atoms be equal to that equation?
That's a good question. Oh, and I forgot to really finish this. Be 1.22 times 10 to the 23rd molecules. Well, let's think about a molecule of water. H2O is the formula. How many atoms are in that molecule? 3. There are 2 atoms of hydrogen. 2 atoms of hydrogen and 1 atom of oxygen. So there's 3 atoms in the 1 molecule. This is not asking us how many atoms are in that. It's asking for how many molecules. So it's this formula here.